For deterministic maths, everything has to be exact. Moving on. Sine and a cosine. So the first question is, we're going to question 6. So the first thing is it bigger and smaller? And symbolically, it's certainly bigger and smaller. There's no 2, by the way, here. So again, we need to be careful about that. But let's go looking. So let's start saying our answer is going to look something like this. Where later we're going to commit to all the rest of the stuff. But my form is correct now. Okay. So we're looking for a sine, cosine. There. Okay, so over here we get the sine of add them. Now remember, we call that 45 degrees, it's easier, and call that 45 degrees, so it's minus 45 degrees there. So the sine of the sum, when you add them, the 45 degrees cancel, and you get the sine of 2x. Cool. Plus, that decides that has to be plus, and now the sine of the difference. So when we're differencing them, the x's go, and we're getting 45 minus 45. That's 90. The sine of 90 is 1. Let's go. Sine of 90. Now, have we answered the question? Yes and no. We're not finished. We're not going to get full marks, because this will simplify. This will not simplify. There's no dividing into 2. Please don't do that. Okay, this is not linear, so there's no way that can happen. Sine is not linear, it bends around, so there's no way you can divide it 2. Okay, if you had a 6x over 2, you can divide it into 2, because 6x is a straight function. This has to be a linear function for that 2 to go in. And changing the angle linearly this way does not cause is not a linear relationship. All you can do is look at the graph of sine, you know it's not linear. So no, never. Sine of 90 is 1. Now, push comes to shove and you're only starting your study and you've missed bits. You shouldn't have to, but you can. Use a calculator, of course. Or you can just come along here and look up the sine of 90, because it's here in the special angles. Okay? But you really should know that as like the back of your hand. I don't know how. That's like knowing 2 plus 2 is 4, to be honest. Okay, you've got to know your sine of 90 is 1. But in a fix, go to page 13. And know how far you have to go to get there. 1 page. So you're 1 page back to, what's the cos of 90? And if there's one thing worse than remembering things in your head, there's one thing worse, and that's thinking you know it and getting it wrong. So if it's a choice between that and going to page 13 or actually calculating in your calculator, then go for it. And be careful you're in degrees if you're using your calculator. Unless it's naught. If you're getting a cos or sine of naught, it doesn't matter what unit you're in. Okay. So what I'm saying is basically the answer here is the sine of 2x over 2 plus a half. And double check have you answered the question. Express each of the following as a sum. I have. Now we're going to have great fun looking at them, and it's silly them. They made a mistake again as far as I'm concerned, because they didn't answer the question according to what they asked. Okay, that's that one done. So we move on to the bottom. And I think these are the ones where basically I slightly misguided you today and in the lesson. But we'll... okay, all's well that ends well. And I was just taking you the long way around. You can say I was building in a bit of extra algebra. But we can go to the... Once you're not starting with a product... So think about here as you read this. If you're not starting with a product, as in these products, then get out of here and come down here. So if you're finishing with well, we don't even know we're finishing with a product yet with these, because we haven't got the answer yet. So it's going to be the answer. If you're starting with a sum or a difference, then you want to be at the bottom of the page in order to get the answer as quickly as possible. So, and again, because the same rule applies for the big, small, because we're going to be getting a difference. So we want the big one up front. So more of that, we'll have to tackle that here. And just here, this will be the only one where we'll have to do a rearrangement. Okay, so anything else I want to say? Well, let's go look searching. I'm looking for a cos. Top. Cos. So carefully working your way along here, you're literally going double cos. 7 and 2 is 9a. And there's your mixture of parity, and parity as in even and odd. And if you're mixing even and odd, expect the fraction to survive and to stay there. Okay, so you got double the cos of 9a over 2. Moving your finger on here, just bringing it on to the next little bit, and you got another cos. So it's all cos's here. Cool. Cos of, the big one take the small one, is 5a over 2. And that 2 being part of the formula. And that's that finished. Okay, question 7. Double the cos of 9a over 2 times the cos of 5a over 2. Cool. On to number 8. We're looking for sine. Let's get to know this as much as we can. If your sine is at the third spot. Okay? Well, actually, it's, yeah, sine plus sine. Remember, you don't mix up your sines and your cosines. Either in these products, over here you don't mix them up and here you don't mix them up, because these are the same thing. If you go across that way, these are the same thing. That and that are kind of the same thing. Okay, so we're here with sine sum. So double the sine of 8x, but these are both even, so we know there's going to, these are both odd. I can hardly convince you they're both even. These are both symbolically even, so they're both, they're odd. They're both they're both odd, so 8x over 2. So you should distribute that division, and then you can think of the average of them. So that's 4x. And keep your finger on this or a ruler on it, and move over here. And don't be don't be too. Being modest helps when you're doing these. Don't think that you're brilliant and you're not going to make a mistake, because if you do, you possibly will make a mistake. Okay, 5, and get to know the way our way around here. 5x take away 3x is 2x. We know it 2 is going to go in, because if 2 goes into the first, 2 is going to go into the second. So 2x divided by 2 is x. You can certainly keep that extra line in there if you wanted to before, but you arrive at this junction point. Okay, certainly we can look at them and say, yes, they got that right. Let's do that each time, even though you won't have that in the exam. So it's a sine, it's a difference of sines now. The difference of sines is at the bottom. I might just decide to learn that off. The difference of sines. You certainly want to learn the English around these things. The difference of sines is at the bottom. So basically I kick off, I know it's a difference of sines, I like it the fact that it's big then small. So I kick off and I just go for double the cosine. Now they're both odd as well, so I know the 2 is going to go in. So 5 theta and 2 theta. But this time I'm going to write it out explicitly first, but I know full well that I will not stop there. And I know full well I will not stop there. Okay, because I know, because they were both odd, that this 2 is going to go in. So 6 divided by 2 is 3 theta, and 4 divided by 2 is 2 theta. Okay, the problem with this one, okay, moving on, the problem is probably supposed to go over here now. Okay, let's correct them, check they got it right. 2 cos 3 theta sine 2 theta for 9. 2 cos 3 theta sine 2 theta for 9. Full marks to the author. Okay, over to 10. We like the fact that it's big, small. We're looking for the difference of cosines. The difference of cosines is in the second slot here. We're gone over here and there's a sneaky little minus at the beginning here. So we're going to put that sneaky little minus in. Minus. Let's put it. Let's run up here. Let's go up here. Minus double. So the sine of what you get when you add them divided by 2 and 8. Am I gone to the wrong question? I'm going to the wrong question. That's a disaster. Okay, here 2. Okay, I'm okay. Back on track. So we're mixing odd and even, by the way. So the 2 is going to survive basically down bottom. So I'm adding them to 11t over 2 sine 11t over 2. And I would maybe encourage you just to do one step at a time. Once you've read sine, don't start trying to work out the rest. Make sure you write down once you get there. Just do one thing at a time. Now 7 take away 4 is 3t Don't forget you divide by 2. And that's not going to go anywhere. That's not going places. That's done. 10. Minus 2 sine of 11t over 2 sine of 3t over 2. We're on to question 11. Okay, so question 11 I'm going to write as the cosine of 8x plus the cosine of 4x. We're looking for the sum of cosines. If I remember right, that's at the bottom. No, I'm totally wrong. It's at the top. Give it a go. Try to remember it. Get it wrong, then you improve your learning and you dismiss false inklings about knowledge. All right, so the sum of the cosines is at top. Sum of cosines. We move over here, and then it goes to explicitly break out the steps into write down your double, write down that cos, deal with the sum over 2, 12 over 2 is 6x. Deal with this cosine, write it down before we even worry about dealing with this. 8 take 4 is 4, 4 over 2 is 2x, and we're done. Okay, that was number 11. Double cos 6x cos 2x, cool. Okay, sine, sum of two sines, and again, oh look at that, 90 degrees and negative 90 degrees is the way I'd go with this, and otherwise we might feel just a bit uncomfortable. Maybe you do, maybe you don't. Once you get into third level and once you get into advanced mathematics, basically it'll be kind of shunned upon to write with degrees. It's kind of a just basically they're not the standard units of maths, but in school maths they are. Degrees measure is part and parcel of what we do. There's only every now and then when it comes to calculus, which you're going to be doing in 6th year, you need to worry about just never using degrees when you're in calculus. You'll understand once you do the chain rule in calculus. You might just remember me mentioning it. Okay, so we're talking about sine, sum, sine. So the sum of two sines. So the sum of two sines is in the second last slot. So we come over here and we meticulously work our way through. So we say it's a double, it's a sine, and we start worrying about trying to add them together. You hope you can see that the 90 degrees cancel and we get 2x. Do not forget to divide that by 2. So if we're dividing it by 2, that's x. Carefully moving on to cosine. And carefully moving on to a difference. And in the case of the differences, the x's will cancel. And you'll have 90 minus minus. That there is 180 degrees. Okay. Now a quick drawing might help you figure out, well, what is the cos of 180? And the cos of 180 is minus 1. Again, you know you're one page, you might be one page away. Let's see, do we go all the way up to 180 on this, or do we? No, we freeze it up. We only stay within the principal range, which is the first quadrant here. Okay, but if for any reason you just didn't know, and you should know, let me tell you that, but if you didn't, cos of 180. And when we say you should know, now is the time to learn it. There you do, you see it? Why dismiss that? Why let that information evaporate? The cos of 180 is negative 1. And know it in several ways. Know it from the unit circle. The cos, after all, is a measure of how far you are this way. And by the time you get to 180, having rotated around, you're at negative 1. So if that's negative 1, then this is negative 2 sine of x. Now there you get naught. I might have made a mistake. Sine plus sine, sine plus sine. Double sine, add them, you get 2x. What am I doing, number 12? Number 12, sine plus sine, double sine, add the angles, and you get 2x. I forgot to divide. Did I divide by 2? Oh, I'm here, yeah, that's correct. And then the cosine of subtract them. Oh, look, hold on. You know, subtract them and you get 180. I forgot to divide by 2. And look, if in an exam situation I would have had no way of checking. And I just, to be honest, when I was looking at this answer, I saw that one. So anyone can make a mistake. I wasn't careful enough. And in that sense, maybe less mental maths. Maybe more writing out each and every single step, including that divide by 2, because look how little it was there. So that should have been cos of 90 degrees. And then nothing here matters because cos of 90 takes it down, because cos of 90 is not. Sorry about the lecture. I mean, it's still true that cos of 180 is -1. It's just totally irrelevant for this question. So that's question 12. We're on to question 13 now. And I suppose we're going into the, we're reminding ourselves of the title of the chapter. This chapter is all about identities and proving identities and so on. So using the formula from this page is only a preliminary opening move. So we have the sum of two sines. The sum of two sines is here. So we might start speeding things up, but at the same time, I have to remember what the other thing I just warned, strategy I just spoke about, is being extra careful. So no harm in writing out a few steps. So 2 times the sine. I know I'm on the right line, and I'm getting 4 theta over 2 is 2 theta. Times the cosine. I suppose I'll just say I'll be extra careful about dividing by 2 from now on. It doesn't mean that I start caving in and doing every single calculation out explicitly. 3 theta take theta. I can do that in my head. That's 2 theta. Just, I'm not done yet. Quite complicated to do this. I also have to divide by 2. So 2 theta over 2 is a single theta. Okay, now you might also want to say, well, what's your overall plan here? Well, I just don't really, let me just say I don't really have one bar to kick this thing around here and see what happens. But also to say that products are way better than sums, because you can cancel up and down. Okay? And also you should think about getting rid of tans, and just, we can write that as sine of 2 theta over the cosine of 2 theta. You don't have to. You could also, we'll end up with tan of 2 theta on the left if we don't.